Mr. Burgess. Today we're talking about functions. Functions have a lot to do with the linear equations that we've been working with the last few weeks. In fact, they're just another form of equations, the kind of equations we've been working with. So let's move forward. And you got an outline of your notes that are available to you. So hopefully you're looking at those as we go, so you don't have to write so many things down. So here we go. So our objective is to understand function vocabulary. So there's a lot of words that we use when we're talking about functions that we want you to understand. To identify functions from relations, to use the vertical line test to determine if something is a function, and to identify the domain and the range of a function. So first of all, let's start with the word relation. A relation is any set of ordered pairs. A relation can be represented as a table, or what we call a mapping diagram, a graph, or as a set of ordered pairs. So this first representation is just the XY table. Second representation is a mapping diagram that shows how the one variable or one number in the input is matched up to something in the output. Another one could be a little diagram like this, where you're actually showing different words and then what number they correspond to. And then the last one is just what they call a set of ordered pairs. So you actually have set notation with set brackets. Then you have the ordered pairs set up inside of that set. Okay. So think of a function as a relationship that pairs exactly, or each input with exactly one output. So when we think of the equations that we've been using, y equals mx plus b, this is an equation written in what we call function form. So here's the output, and then here's where we put in our input. So if we put a number in to this equation and then multiply it by the slope and add the y-intercept, whatever those numbers are, we get an output. So if you think about it, an equation or a function like this is like a little computer program. You can put numbers in, input numbers in for x, and then out comes an output, which is actually the value for y. And so that's kind of the beauty of having these functions, these equations, so that we can use them to input data and get out data that we're looking for. So if I put in some numbers, the numbers that I'm putting in, these x values are called inputs. If I plug one in, then it goes into this little computer program, if you will, this little equation and or function. We put in the number and we do 3 times 0, and 0 plus 4 is 4. So you can see how each of these inputs will result in a certain output. Okay, the input values are the values that you put in the function, and they are the x values. The output are the values that come out of the function after you've given the function some type of an input in x. Okay, another name for the inputs is, or the set of all the inputs that you put into a particular function is called the domain. So it's all the x values. And on the other hand, the set of all the output values, all the y values that are resultant from the inputs, is called the range. So here's an example. Here's a little group of ordered pairs. We notice that all the x values, the first numbers are 1, 2, and 3. So that would be considered the domain. So if you're asked to find the domain of a relation, that's what you'll do. The range, on the other hand, is just all of the y values. So 4, 5, and 6 are the y values. And then you put those in a little set bracket notation. And that's how you find the domain and the range. Okay, we have this idea of independent and dependent variable. The variable that represents the input values, the x values, it is the value that can be controlled or changed. We get to choose what number to put in. So that's why it's called the independent variable. On the other hand, the dependent variable, the y value, represents what we get out of the function after we have an input. These y values are kind of dependent upon what we put in for x. And so that's why they're called the dependent variable. All right, so let's kind of summarize. All the x values in these functions can be considered or called the inputs, the domain, the independent variable, or another word for it is changes. This number is going to change, and we're going to get a result on the other side. The other variable, the y value, is also often called the output or the range or the dependent variable or the results of what we put in to the function. Functions can be represented in many ways: by an equation, such as y equals mx plus b, by an input-output table that we showed you a few minutes ago, or just using a word phrase. We've looked at those. Or by a graph, or as a set of ordered pairs using those set brackets. So a relation that pairs each input with exactly one output is called a function. So that's kind of where we're starting to use this word function a little bit more. So if you'll notice, we look at this group of ordered pairs, we have 1, 3, 5, and 0 for our inputs, and each one of those numbers has its own distinct output. Now the outputs can be the same, like if you put in 1 and out comes a 2, and if I put in a 5 and out comes a 2, that's okay. It's when we put in a 1 more than once and something else comes out for y. That's when it's not a function. So let's look at an example of that. In this one, we've got 3, 3, 4, 2. All of a sudden, the input 3 comes up again, but this time we get an output of -1. So that right there would result in this relation not being a function. All right, so now we're going to show you that if you have a mapping diagram, which is what these two things represent, how would you write all of these numbers that have been mapped as a list of ordered pairs? Well, this is what they would look like. So the first one would be 1, 3, the next one 2, 6, 3, 9, 4, 12, and so on. On this second one, we have 0 and 0. And the number 2 on the input is paired with two different numbers, 1 and -2, and 4 and -3. So this is kind of significant because when you have the number 2 for your input and something different for your two outputs like that, that means that this is not a function. And we'll talk more about that in a minute. Okay, so list the ordered pairs shown in the mapping diagram here. So let's take a look at those ordered pairs. So if I listed them out, this is what they look like. I noticed that in the second one, number 1 pairs to two different numbers, as well as so does number 2. So this one is not a function, while the first one is, because each of the inputs only pairs with one output. And in this particular one, each input is paired with two different output values, so it's not considered a function. All right, so is this a function? Remember that each input has only one output. So let's look at the first one, -9, 0, 1 input, 1 output, 1 input, 1 output. 5 only goes to 10. And now 12 only goes to 10 as well. So even though these both have the same output, each input only has one output that it goes to. So this is a yes. It is a function. Okay, how about this one? Well, 2 goes to -4, -1 goes to 3. Oh, look at this. 0 goes to 6 and 5, and that's enough to make this not a function. All right, how about this next one? We got 1, 9, -1, and 3. So we've got all of our inputs are different numbers, and so it doesn't matter really what the outputs are. This is a function. So yes, this is a function. All right, keeping going here. Okay, determine whether these relations are a function. So we'll keep that same rule going. I noticed that in the first one, I've got -2 goes to 15, but 0 goes to 10 and to 20. So that means this one's not going to function because of that one arrow that goes to two different places. Well, how about this one? Well, if you notice, each of these arrows go from one number on the left to one number on the right, and they all go to one distinct number, so yes, this is a function. How about this one? Well, each arrow on the left only has one arrow that leaves it, and while you have two numbers who map onto the number 7 on the right side, that makes it still a function, so that's yes, even though it's a little different than some of the functions we've seen. Okay, let's take a look at this last one. We got -1, 8, -1, and 0. So the two we really need to focus on is this -1 here and -1 here. What is the output with that -1 input? Well, this is an output for -1, and so is this. And if I notice, the output is different. For the first time we put in, we got 2. For the second time we put it in, we got 9. So this makes it not a function. So not a function. Okay, keep on going. Okay, for each relation, decide whether it is a function or not a function. So this is what the problem will look a little bit more like when you get into ALEKS. So it's the same idea. You got, in fact, you got words that represent something on the left, and then you got an arrow going from what those represent to a number on the right. Now we notice that 4 different words on the left have one arrow leaving them. They may all go to the same one, but at least they don't go to 2 different ones on the right. And so in this particular case, this is a function. On this one, 0 goes to 9, 2 goes to -2, but 4 has 2 numbers that it goes to, -2 and -7. And so that makes this one not a function. Okay, this next one, we have just nothing but letters, but let's look at the first letter, S, E, Y, and U. All right, as long as the first letters are different, this is a function. And this next one, we got 6, -5, 9, and -6. So all the first numbers are different, so this will be a function. All right, so you'll have a few problems on ALEKS that look like that. All right, so there's another one very similar to that. Okay, so we want to get on to our last one, the vertical line test. A line represents a function when no vertical line, or a graph represents a function when no vertical line passes through more than one point on the graph. So this is a very simple way to tell if something is a function when you're looking at its graph. So you'll notice in our first example here, a vertical line only passes through one point at any one time. So it's a function. Well, the next one, though, has a curved shape to it, and there are several places where a vertical line will hit that graphed line more than once. So that makes it not a function. So let's check out a few of those. Okay, if we look at this, we've got a bunch of dots here, but if I notice a vertical line will hit 2 dots here and then 2 dots here. So that means that this is not a function. And if it asks you to explain, just say you can hit 2 dots with the same line vertically. Here, no matter where I draw the vertical line, I'm only going to hit the line one time. So yes, this is a function. Okay, keep on going. So how about this next one? Well, the vertical line will only hit once. On this number 6, any vertical line will only hit once, even though it's kind of going uphill in both directions from the center. The same with number 8. Any vertical line will only hit once. Okay, however, on number 7, a vertical line anywhere inside of these, the outer edges of this circle will result in 2 intersections of a vertical line. So it'll hit the circle twice. So this is not a function. Okay. So here's what it looks like in ALEKS. You'll just have a little list here. So this one will hit 2 when you do a vertical line test. So this is not a function. Another circle not a line test, or not a function. All of these dots, even though they're spread out, none of them are vertically lined up with each other. So this would be a function. This particular one, you could hit in a couple of different places. So no, it's not a function. Of course, even this kind of wavy little function would be considered or wavy line would be considered a function because it only hits once. Then this last one, number 6, we have a V-shaped graph that's kind of tilted on its side. However, a vertical line will hit more than one time, so no, it's not a function. There's another one that's very similar, so you can just imagine vertical line hits more than once, so no. Vertical line only hits once, yes. Vertical line hits more than once, no. So that's the idea. You go through those. Now, when you have these, unlike number 4, a vertical line will go through one point, but when it goes down to that open circle is not included, so that would not be hitting the line more than once. That would only be hitting twice. Or, excuse me, once in each place. So yes, this is a function. This triangle, however, you could hit in a bunch of different places vertically, so that's not considered a function. All right, and then this last one, all the dots are kind of offset from each other, so yes, this is a function. Vertical line will hit not more than one of them. Okay, so finding the domain and range of a function. The domain and range of a function, okay, the domain of a function is just a set of all the possible input values. And that's an interesting concept because in some equations, it wouldn't make sense to put certain numbers in there. So some of our domains may not be a big long list and forever in both directions. It might be a shortened down list where only the numbers that you put in would make sense. And the range is kind of the same way. So the range of a function is a set of all the possible output values for a particular function. All right, and we told you that all the domains are the x values, the ranges are the outputs. And so if you have a group of dots here on the graph, then just go ahead and write down their ordered pairs like -3, -2, -1, 0, and so on. And then the first digits are going to be the inputs, which makes them the domain. And the other digits are the outputs, that makes them the range. So that's how you would do a problem like that. Okay, find the domain and the range of the function. So the domain, again, is the input values. So I'm going to have 0, 1, 8, 6, 5. Just like that. So there's the domain, and the range is going to be the y values. So those would be 4, 7, 0, 9, 5. Okay, now you'll notice that we put these little brackets around here. And so it's pretty simple to find the domain and the range of this function. All right, so there's a couple more examples of those. And finding the domain and range from a graph. So to do that, you would have to actually look at each dot, say, well, that's -2, -1, 2, 3, -3, -2. And this dot would be -1, 0. This dot would be 1, 2. And our last dot would be 3, 4. And so the domain, the set of all the domain values would be -3, -1, 1, and 3. And then the range values, of course, would be the y values. So those would be -2, 0, 2, and 4. And I put those set brackets around that so that you can see them there clearly. Okay, so we can do this one like that. There's another example. So what we need to do now is you have an ALEKS assignment, an intro to functions, and if you need to, go back and review this video, and it'll help you out a great deal. Thank you very much.